we're just going to get straight into it then. So firstly, we've got our starter questions. So I've been looking at some of your responses. I think what a lot of people have done is find most of you found the critical values okay, but it's just making sure you get that inequality right. So I'll show you how we go through a question like this. Now we've got the equation as given here. We're told that P is a constant and it has no real roots. So what we can do is find the possible values for P. So what we're going to do is, if we're told that there are no real roots, we know that the discriminant b squared minus 4ac, okay, remember that's the bit that's in the square root in the quadratic formula, that is going to be less than 0. So if you look at the equation we've got here, b is the coefficient of x, so that means I'm doing 5p squared, so 5p all squared. The a is the coefficient in front of the x squared, and the c is just that constant term that you've got left over, so that's just simply going to be the p there. So when I square this 5p, make sure you square the 5 as well for 25p squared minus 8p less than 0. Okay, so this is the inequality. Okay, if 25p squared minus 8p is less than 0, then this quadratic has no real roots. It won't cross the x-axis. So what we need to do is find the critical values. So what I do is I set this quadratic to 0 to find these critical values. And then what I need to do is, now this isn't a quadratic that goes into 2 brackets. With this quadratic, I simply take out p as a common factor, as so. And then I can see my critical value is going to be p equals 0 and p equals 8 over 25. So what I'm going to do is I'm going to do a sketch, but one important thing I just want to talk about this quadratic is make sure you factor that p out. Looking at some of the solutions from earlier that you gave me on the forms, and thank you for everyone that did that, just make sure that you don't just divide through by a p, because you lose that solution p equals 0. So I saw a lot of p is less than 8 over 25 or p is greater than 8 over 25. What that tells me is that you probably divided by p and lost that solution of p equals 0. So just be careful with that. So what I'm going to do is I'm going to sketch 25p squared minus 8p. So I've got my roots here of 0 and 8 over 25. Because I'm looking at where this is less than 0, I'm just looking for all the values here between 0 and 8 over 25, because between those two numbers, the graph is below the x-axis. If it's less than 0, I'm looking at below the x-axis. So therefore, simply, I have this as my final solution. Okay, it's between 0 and 8 over 25. So we just leave it like this. Just in regards to some of the answers that you gave me, some of you did give me it as 8 over 25 is greater than p, which is greater than 0. That is technically correct. We prefer to write it like this, how I've done it here. If you did it on the form, it would have told you it was wrong. Technically, it is right to say 8 over 25 is greater than p, which is greater than 0. But we tend to prefer in maths to write it that way instead. Right, and then that's just how you get the 5 marks from the mark scheme. So I'll just allow a chance for any questions that you may have. One thing I will say is we've just uploaded a new piece of homework for over the Easter holidays. So if you can make sure that you have a go at that probability homework, and if you haven't handed in anything, handed in the previous homework, make sure that you have a go at that and you've done that if you've been late with that. But yeah, you should see your probability homework on Teams now. So I'll just double check the chat to see if there's any questions before we move on. No worries, Lewis. Right, no questions. Okay, so let's just move on to probability formulae. So this is actually good. There's quite a lot in this lesson. So if I'm going a bit too long, I might possibly miss the last past paper question, but let's see how we get on. So this first formula is something that we've pretty much been using already. In the last lesson, we pretty much came up with this formula for ourselves. If you can't remember this is in the formula book on page 7. Okay, so in the exam you get a big formula book, and this formula is in there. And just to remind us where this formula comes from, we know if we've got the probability of A or B, we're looking at everything within the circles. So if I add the probability of A and B together, the problem with just adding the probabilities of A and B together is that I've been including that overlap twice. So that's why I have to take away the probability of A and B from it. So let's go straight into our first example. We've got two events and we've got given probabilities for A and B, and we're also told the probability of A or B is 0.9. And we're asked to find the probability of A and B. So if we look at our formula, this is telling us what the probability of A or B is. We want to find the probability of A and B. So all I'm simply going to do is going to add the probability of A and B to both sides, and I'm going to take away the probability of that's in the red box there. The way it works. So I want to work out the probability of A and B. What I have to do is simply just add the probabilities for A and B together. So add the 0.6 and the 0.7 together, and then take away the probability of A or B, which is 0.9, and that gives me an answer of 0.4. Okay, and that's all there really is to that first question. So I'll do the second examples and I'll check if there's any questions in a second. So moving on to our next example, we're told two independent events. Okay, that's really important. A and B are such that the probability of A is a third and the probability of A and B is a 12th. And we're asked to find the probability of B and the probability of A or B. So I mentioned the fact that they're independent is important. That helps us greatly in this question. So because they're independent, this means that the probability of A times the probability of B equals A. The probability of A is A. The probability of B is what we're trying to find, and the probability of A and B is a 12th. Rearrange this and we get probability of B is simply just a quarter. And then for part B, we've got the probability of A or B. So we just simply use the formula that we were given earlier. So it's just the formula at the top in the red box, the probability of A plus the probability of B minus the probability of A and B. Since part A, we now have all that information to do this. So it's a third plus a quarter minus the probability of A and B, which is a 12th. And we just get a half as our answer. Right, so I'll just have a quick check in the chat if there's any questions. If not, we'll move on to examples 3 and 4. Okay, so we've got some more probabilities here, and we've also got a Venn diagram here at the side. This will help us. especially when we get to parts C and D. So firstly, the first question is just asking us, what is the probability of A? Now, in the question, we're told the probability that it isn't A is 5/8. So this is nice and simple. The probability of A is just 1 minus the probability of not being A. Okay, either A is happening or it's not. So we just do 1 minus 5/8, which just gives us 3/8. And then for part B, so now what we're going to do is start to fill in our Venn diagram. So we know that everything in the circle for A has to add up to 3/8. Okay, so from part A, because the probability of A is 3/8, everything in that circle has to add up to 3/8. We're also told the probability of A and B is a quarter. So I know a quarter goes in the center of my Venn diagram. And then this means an 1/8 would have to go here. And that's simply just because all of this circle has to add up to 3/8. So if I add the 1/8 and the quarter together, it's going to give me 3/8. So I'm also told the probability of A or B is 7/8. What that means is everything in these circles needs to add up to 7/8. Okay, so all the parts within A and B need to add up to 7/8. So to work out this missing section here, add together what is already there, and then just simply take that away from 7/8. When we do that, we get a half. So for the probability of B, this is, I just add up everything that's in the circle of B. The whole, everything that's inside circle B has to add up to 3. Has to add the probability of B. So I add the quarter and the half together, and I get 3/4. Then we're going to look at the probability of A and not B. To do that, just simply look at the Venn diagram. A and not B means both of these events need to be happening. So I know that A has to be happening, and also B has to not be happening. The only case where that is happening is just where I've got that probability of an 1/8. Okay, so just in this diagram, this is where A is happening and B is not happening. And then finally, part D, probability of not A or not B. Well, if you like, you can start drawing some crosses to show where this is happening. So if I put a cross everywhere where A isn't happening, and I'll put a blue cross everywhere where B is happening. Okay, all I've got to do is satisfy at least one of those conditions. The only place where neither thing happens is just that quarter in the middle. So you just add up your probabilities of the half, an 1/8, and sorry, this should all add up to 1, remember, in the rectangle, so we should also have an 1/8 here. So we add together all those probabilities, and we just get 3/4. Alternatively, because it's saying the probability of not A or not B, basically that just means as long as both aren't happening at the same time, the condition's been met. So I could also just do 1, take away a quarter as well, if I so choose. We'll have a look then at example 4, and then we'll move on to the next section of this. So firstly, we've got some probabilities here, and we've got a Venn diagram. So I'm just going to stick everything in that Venn diagram. The 0.25 goes in the middle. Everything in circle A has to add up to 0.4, so 0.15 goes there, and everything in circle B adds up to 0.5, so 0.25 goes there. And not forgetting, I'll make sure I put it in earlier this time, 0.35 that goes on the outside. Everything inside that rectangle needs to add up to 1. So the first question is, what's the probability of A or B? Okay, so just in the chat, can you put in what do you get as the probability of A or B? So what's the probability of A or B? Excellent. I can see a lot of 0.65. So hopefully we'll agree. Just everything inside those circles there. So whilst it might look like it's quite 6 questions here, a lot of these are quite quick and easy, these ones. If the probability of A is 0.4, the probability that it isn't A is 0.6. If the probability of B is 0.5, the probability that's not B, we just do 1 minus, and we get 0.5. Okay, yeah, again, I'll put this one to chat. What's the probability then of not A and not B? Okay, so I'm going to ask you to do D now. What's the probability of it not being A and not being B? Okay, and excellent. I can see a lot of 0.35s. So that is just if it's not A and it's not B, the only place that we can look at is just that 0.35 that's on the outside. So fantastic. Put 0.35 in there. Then we've got the probability of not A or not B. What I do there is I just add up everything apart from that 0.25 in the center. So just do the 0.15 plus the 0.25 plus the 0.35, and that will give me 0.75. Alternatively, I could just do 1 minus 0.25. And then finally, the probability that it's A and not B is just simply 0.15. It's just simply this part here, because this is where A is happening and B is not happening. So if you've got any questions, please post them in the chat. We're going to move on to the second part of this, which is look at the multiplication formula now. But yeah, again, you do get this next formula in the formula booklet, so that is one good thing. Right, can't see any questions, so we will move on. So for two events, A and B, the multiplication formula for conditional probability states that the probability of A and B equals the probability of A given B multiplied by the probability of B. So this is one way of writing it. In the formula book, they actually give it to you as this instead, which is also valid. When you're doing this, basically think of it as whatever letter you have here should be the same letter you have here. So here we've got probability of A given B times the probability of B, or we could say probability of B given A times the probability of A. We could rearrange it to also think of the formula like this. The probability of A given B equals the probability of A and B over the probability of B. Now we pretty much use this formula in Tuesday's lesson. So I'll just show you how we can actually prove that formula. If I draw a Venn diagram here, now if I'm looking at the probability of A, given that B has already happened, remember from what I do from Tuesday's lesson, I would need to restrict my sample space. So if I'm given that B has already happened, I'd have to restrict my sample space to just this. And if I'm then looking at the probability of A, well, I can only look at where A happens within that restricted space. So this is where that formula, so I'm looking at the probability of A given B, well, I simply would just say on the bottom of my fraction just goes the probability of B, so my restricted space, on top is anywhere where that event is actually satisfied. So where is A happening within that given space? Well, that's only where A and B are intersecting. Okay, so that's how we get that formula. And I can also think of it the other way around. The probability that B happens given A would just be the probability of A and B over the probability of A. Okay, so if I do probability of B given A, I restrict my sample space to A. So that's what goes on my denominator, and the numerator is just, yet again, it's the intersection. There's a couple of things that you've got to be careful with here. Now, the probability of A and B is the same as the probability of B and A. So I can change those letters around. What I have to be very careful with, though, is generally speaking, the probability of A given B does not equal the probability of B given A. Occasionally it will, but it's definitely not always the case. So we have to be careful there. We can't just switch the A and the B around for the given that, but we can for the intersection. So just take care to do the following questions, because it won't always be A and B. As we'll see, we're going to have C, D, L, W, P, all different kinds of letters as we go along. Probably not P, because that's probability. So we're going to get straight into example. I'll just double check the chat again. Nothing there. So we've got two events C and D, and we've got the given probabilities for C and D, and the probability that C happens given D has already happened is 0.3. So first things first, we're going to find the probability of C and D. So what I'm going to do is the probability of C and D, that would just be the probability of C given D times the probability of D. Yet again, because I've got the D last, I times it by the probability of D. If it was probability of C, if it was the probability of D given C I had, I would times it by the probability of C instead to find out the probability of C and D. So that's just taken from that formula there above, but instead of A and B, I've just now got C and D instead. So with that, I can just sub in the probability. So I just put in 0.3 here, and probability of D is 0.6. So I just get 0.18 as my final answer. The second question is asking for the probability of D given that C has already happened. Remember, this is not simply the same as saying the probability of C given D. So what I'm going to do here is use that second formula. So the second way I could write it, the probability of A given B equals the probability of A and B over the probability of B. So I'm going to write the probability of C and D on top. Remember, I can think of that as the probability of C and D. I can think of it as the probability of D and C. That order doesn't matter. It's the given that probabilities where the order does matter. And on the bottom, I'm going to do the probability of C. Yet again, because I've got the C last here, I'm going to do probability of C here. The probability of C and D, well, I just worked that out. That's 0.18. And the probability of C, that's given to me in the question, is 0.2. So my probability is simply just going to be 0.9 or 9/10, if you will. Finally, we're working out the probability of C or D. And to do this, we simply just use the formula that we were using earlier. So we'd have to, just right at the start of the lesson, we're going to add the probabilities of C and D together. But then we just take away the probability of C and D. So we just take that from part A. And we get 0.62 when I do that. Okay, so if you do have any questions on that, please let me know, because that's a little bit different. to what we were doing before, but I say we kind of did actually use that formula when we was doing the conditional probabilities earlier. Right, let's get on to the past paper questions then. I think we're going to have time to do them both now, actually. So, first question then. We've got L is the event that Marta arrives late, and R is the event that it's raining. And we're given the probability of L, we're given the probability of R, we're also given the probability of L given R. Use this information to show that events L and R are not independent. Now, so far, mostly what you've been doing to show events are independent, you've been doing the probability of L times the probability of R equals the probability of L and R. But we don't actually have the probability of L and R here, so we'd have to do some further calculations to work that out. However, look at how many marks this is. This is 1 mark. So I'll put this question in the chat. Can anyone tell me a very quick way I can show the probability that the events L and R are not independent? So can anyone tell me, explain to me why, in a very quick way that's it's a 1 mark question, why L and R are not independent? Okay, without using the probability of L and R doesn't equal the probability of L times the probability of R. It's something we mentioned in Tuesday's lesson. No one gonna have a go? So there is a way we can check, and this also is in the formula book, to check if an event is independent. So another way we can do it with the given that. And that's that if we do the probability of L given R, well, this would just equal the probability of L. Because remember, if an event's independent, it doesn't matter what's happened before. The probability of L, given whether R has happened or not, will still just be the same probability. So if the probability that L happens is 0.15, well, if it's independent, it doesn't matter what the probability of R is, the probability of L should still be 0.45. Now, in this case, the probability of L given R is 0.45. That does not equal the 0.15. So therefore, those events are not independent. Okay, so it should be the case that, let's make that smaller. It should be the case that L doesn't, if it's independent, L doesn't care about what the probability of R is. It doesn't care that R has already happened. But here, clearly, it makes a difference. Given that R's happened, the probability is multiplied by 3. Okay, so that's a very quick way to check if events are independent, if you've got the right probabilities as we have here. So part 2, find the probability of L and R. Okay, so no, we could have done it the other way that we're doing it before, but this is just an alternative way that we could do it, and it's very quick, as you can see. So to do this, use the new formula that we've got. So we use the probability of L and R equals the probability of L given R times the probability of R. So just multiply 0.45 by the 0.22, and we get 0.099. Okay, yet again, remember, in terms of the order, if we've got the probability of L given R, we need to multiply it by the probability of R, not the probability of L. If we had the probability of R given L, then we'd multiply it by the probability of L. So the 0.099 goes in the center there. The whole of that circle for L needs to add up to 0.15. So on your calculator, you'll find that you just need an extra 0.051 there. Everything in this circle for R has to add up to 0.22. Yet again, pop it in your calculator, 0.22, take away 0.099, and we get that. And then everything in the rectangle has to add up to 1. So add that up and take it away from 1, and we get 0.729. Just have a look at some questions. Okay, so if you've got any questions, let me know in the chat. If not, we'll move on to our final example. Okay, so Alan drives to work and he goes over a level crossing, and W is going to be the event that he has to wait at the level crossing, and L is the event that he is late for work. So you can imagine that obviously one would have an impact on the other here. So we're given that the probability of L given W is 0.4. We're given the probabilities of W and the probabilities of L or W. The first thing we're asked to do is calculate the probability of L and W. That's what we're doing right back at the start of the lesson. So we use the probability of L and W. Sorry, not right back at the start of the lesson. The formula we just met a second ago. So if I want to work out the probability of L and W, we do the probability of L given W, because that's what we've been given. And we have to multiply it by the probability of W. So got a W there, so also have a W there as well. So the probability of L given W is 0.4. The probability of W is 0.07. Multiply them together and we get 0.028. Draw my Venn diagram. So L and W, that's going to go in the center there. We know everything in the circle for W has to add up to 0.07. So I need a 0.042 there. And then we need to find out these other numbers. We know that the probability of L or W is 0.08. So everything in these circles needs to add up to 0.08. So we need a 0.01 there. Yeah, again, this is all just from doing it on your calculator. You can check these later if you don't believe me. And then we just need to complete the rest of the Venn diagram. So we need a 0.92 on the outside here, because everything inside the rectangle has to add up to 1. So that's your part 2 done. And then finally, part 3, we can determine whether events L and W are independent. And to do that, well, we can simply do what I was talking about earlier, as we did in the previous question. Now, the probability of L, we're not given that. We do need that here. The probability of L is going to be 0.038. Okay, that's what happens when I add everything in that circle for L. We're also given that the probability of L given W is 0.4. So we can clearly see there the probability of L given W does not equal the probability of L. Therefore, they are not independent. Because clearly, W is, if you have to wait, clearly the probability you're late, given that you have to wait at this crossing, clearly the wait time waiting at the crossing has an impact on whether you're late, which is what you would probably naturally expect anyway. You can see there the probability that you're late is quite low, but if you have to wait there, that probability is greatly increased. Okay, so you can see there that they can't be independent. Surely there is some dependency on those two events. Now that is one way you could do it. We've worked out the probability of L there. We could also just simply do the probability of L times the probability of W, and we can show that we don't get 0.028 for the probability of L and W. So you can use either, you can do either way and you'll still get the marks, but just showing you the two different ways. And also it depends on what information you've been given as to how you could work these things out. So I'll just allow some questions if anyone's got them. I'll stop the recording here.